Okay, this is Unit 7. It is Lesson 1, and this unit deals with probability. It corresponds to Chapter 11 in our textbook, but I really like these lessons a lot better, so I hope you will enjoy them. It does correspond with a lot of group work, so you don't necessarily need the video. Everything that you have is written there for you, but just to give you a little more explanation, if you want it, then here we go. I will tell you, again, I'm very sorry that I can't be with y'all, but more importantly, probability is a lot about reading and becoming familiar with the problems and how the questions are asked. So I can't emphasize enough, not necessarily a lot of work to do, but you got to know what the questions are asking each time. So the two main types that you're going to have, first off, we have a general multiplication rule. And it comes from when you are trying to find the probability of two events, A and B. They occur at the same time. It's referred to as the intersection of those two events. Okay, and you can find the intersection of those events. Let me go back to this. So and you will see this symbol referring to and. So when you are asked the probability of A and B, those events happening, then you're going to remember, or you want to remember, that that is when you're going to multiply the two probabilities together. Okay, so another thing that you have to know before we go on is something referred to as conditional probability. Okay, it is denoted with this notation right here, and this says the probability of event B given event A has occurred, which is right here for you in words, but you want to remember that this line right here is read given, and you read it in order. So it's the probability of event B given that A has occurred. All right, and so the formula for and the intersection of two events is right here, and it says the probability of A and B is the probability of A times the probability of B given A. Now, one thing that's really important that I want to add to that is what happens if that changes the order. So if it could also be written the probability of B and A equals the probability of B times the probability of A given B. So keep that in mind when you are finding the intersection of two events. Okay, so this first problem says, suppose 35% of farmers in a farming community grows carrots. Okay, well, I'll go ahead and read the whole problem. And 70% of the farmers in the area grow peas. If the probability that a farmer grows carrots, given that he grows peas, is 40%, what is the probability that a randomly selected farmer grows carrots and peas? So we are definitely looking for an intersection. And if you notice, this says the probability of a farmer grows carrots and peas, but they set it up as peas and carrots. But as I just said to you, order doesn't necessarily matter. What they have given me, it's going to change this thing a little bit. Let's see what happens. So suppose 35% grows carrots. So the probability that the farmer grows carrots is 0.35. Keep in mind we don't ever use percent in mathematical equations or problems. All right, and then 70% grows peas, so the probability of peas is 0.7. Then the probability that he grows carrots given that he grows peas. The probability that he grows carrots given that he grows peas is 0.4. So that is the one right here that ties into this formula, which is why they have written it like that. You will get the same thing, so you don't need to worry about that. Just understand from our original problem here which given that you need in the problem. Okay, so we're looking for the probability that a randomly selected farmer grows carrots and peas. So the probability of peas and carrots is the probability of peas, which is 0.7. Actually, I gotta put that whole thing in there. So it's the probability of of peas, which is 0.7, times the probability of carrots given peas, and that is 0.4. So the probability of carrots and peas is 0.28. Or the probability that a farmer in a community grows carrots and peas is 28%. So a lot of times in words, we use the percent. In equations, we use 0.28. When you give the answer to these problems on test, there's no quiz for this unit because it's so short. But when you give your answer on the test, you can either give it as a decimal, as a percent, or as a fraction. So just keep in mind, it does not matter, but what does matter is that you show me this line right here, this information. You cannot just give me 28% and not show me what you did with the numbers in the problem. So another thing that I kind of want to point out to you before we go and talk about the addition rule is to kind of give you a picture of what we've just talked about here. Okay, some people, I don't know if you remember these little things called Venn diagrams. Okay, and if you have the probability of, I don't know that I drew that big enough. Let's go that little, didn't want all that done. Let's do this. All right, so we have the probability of the farmer growing carrots and the probability of a farmer growing peas. Okay, and then the probability that he grows peas and carrots is 0.28. That is this part right here. That's the intersection of peas and carrots. And so when you talk about the probability of him growing carrots is 35% or 0.35, you've got to think about this whole circle being 0.35. So that makes this little part 0.07. That doesn't look very clear. I'll try that one more time. That's better. Okay, and then if the probability of the farmer growing peas is 0.7 and this part is 0.28, then these two numbers together have to add up to 0.7, which makes this 0.42. And that's my crazy, there we go. Okay, so keep that in mind because now we're going to talk about the other main types of problems that you're going to have in probability, and that is the general addition rule. And the general addition rule is when we're talking about A or B happening, and it is referred to as the union of two events. So when you see that, actually I'm going to go highlight, here is our formula, and I'm going to explain that in just one second. So what's happening here is, come here. All right, so what I have, the probability of A or B is the union, and the union symbol looks like this, as you can see in that problem right there. Okay, so if you have and, you multiply. If you have or, you're going to add. That's the key thing that you got to remember throughout this lesson, throughout this unit. The union of two events is determined by adding the probability of the event A to event B and subtracting. This is the key thing a lot of people forget. The intersection of the two events, or sometimes people like to refer to it as the overlap. Now, if you think about our peas and carrots, well, this is what they're asking. Look here. Referring back to the farming example, the probability that a farmer grows carrots or peas. Now, if you think about just adding that, then peas or carrots is going to be 0.35 plus 0.7. Well, I don't know if you figure out, but that is 1.05, which is over 100%. Okay, so keep in mind that the smallest of probability, every probability that you have has to be greater than 0. It can be equal to 0, and it has to be less than or equal to 1. You can never, ever, ever have a probability larger than 1. So if you're thinking about the probability of carrots, which is 0.35, plus the probability of peas, which is 0.7, that itself is more than 1. So it might help you remember that you've got to subtract the overlap. And what's happened, if you look at this visual up here, you've added 0.35 and you've added 0.7, but you've added that number twice, which is why we subtract the overlap of 0.28, and that gives us an answer of 0.77. I gotta pause for 1 second. So the probability the farmer grows carrots or peas is 77%. More importantly, please remember, okay, as I'm trying to point out right here, that your probability will always be between 0 and 1. And especially when we get into something called permutations and combinations, if you'll remember that concept, you will, it'll help you kind of get the right answers. Because really what people miss on these problems is just reading and making sure they understand what the question is asking. Okay, for our next one, pause. Okay, turn your page. The next thing we have is something called a frequency table. This is actually a two-way frequency table. And when you have this table, I think it actually makes the probability finding much easier. So I'm going to show you kind of a little shortcut and how to read these tables. You can go practice them in IXL. They're great. But you can always use the formulas that we just talked about on the front page. That will work also, but this, I'm just showing you a more direct route of answering the questions when you have this table. So what we have here, juniors and seniors at Memorial High School who drive to school have two options for parking. There's a reserved lot on campus that charges $10 per month to park, or students across the street in an open parking lot for free. The table shows the distribution of student preferences for parking by class. So if a student is randomly selected from the students who drive to school, what is the probability that a student is a junior? Okay, and I'm going to add the notation. When you work these problems, y'all, if you will put the notation down when you do it, it gives, I think, a lot of understanding and helps me know whether or not you understand what you're doing. So what they are looking for, or what they're asking, is the probability of a junior. And a straight up probability is what I'm looking for, or what we call favorable or possible outcomes to the total. This is favorable over total, is what that is. So if I'm selecting students from the school, what is the total number of students? Clearly that is 650. Always right here. I will tell you this, if you do this in IXL, a lot of times you only get these numbers right here. They don't give you the total, so you have to actually go find them yourself. It's just a little bit of work. Okay, and of those 650, how many of them are juniors? Well, juniors, go over to the total, and I have 250. And then, of course, you always simplify that. Divide top and bottom by 10. 25 over 65, you will be using a scientific calculator or graphing, it doesn't matter on this unit. 25 over 65 reduces to 5 over 13. And this is where I do think it's easier to actually leave it as a fraction. Don't, I mean, it's an extra step to change it to a decimal. If you use the fraction button on your calculator every time, it will give you a fraction in simplest terms. Okay, moving on to, now, these keys, this first one that we had straight up is a junior. When you read these rest of these, there is a key word that you need to look for every single time you do those problems. So in this particular one, what's the probability that a student parks in the reserved lot and is a junior? Okay, so what you want to remember, and as we talked about on the page before, refers to the intersection. So you're looking for the intersection of reserved lot and junior. So reserved lot and junior is 75. I'm going to go ahead and write that. So this is the probability of reserved and junior. How many students do we have that are reserved and junior, or the intersection of the reserved lot and the juniors? And that's 75 over total number of students, 650. And when you reduce that with your handy dandy calculator, you will get 3 over 26. And like I said, you can go do this with the formulas that we talked about on the page before, but when you have a table like that, I think this is a lot easier. All right, we're going to keep going. Number 2, looking for that key word. Is a senior given? Not and. Where's one? This one is an and. This one is an or. This is a given. When you have a given, that means you have a new denominator from any of the other problems. Okay, we're going to write, it's the probability is a senior given that they park in the open lot. Okay, now a lot of people like to think about this toplet over. So this is the one that's going to go on the top, and this is the one that's going to go on the bottom. Okay, so that being said, I have a new denominator. I do not use 650 like I did in the last ones. I need to know how many are in the open lot. And when I look at the open lot, okay, I have total in the open lot is 450. And how many of those are seniors? 275. So 275 over 450 with your handy dandy calculator is 11 over 18. So that is your answer. All right, look at the next one. What is my key word? What's the probability the student is a senior and parks in the open lot? Probability, senior, and parks in the open lot. That means I'm looking for the intersection of senior and open lot. That's this number right here, which is 275. And my total, oh, don't go anywhere. My total, stop it. All right, stay. Okay, 275, and I don't have given in here, so my denominator is the same that I've been having, which is 650. And when we reduce 275 over 650, you get, don't, yeah, I didn't have this because I had y'all do it yourself last time. So anyway, that simplifies to 11 over 26. Okay, and so on this last one, so what I've done in this problem, y'all, is covered every single type of problem with a frequency table. So you should have no trouble doing all the ones that are in the rest of the packet. Sometimes you got to work backwards. So, all right, what's the probability that it is a senior or parks in the open lot? And an or, remember, is union. So this means I'm going to add up all the different ones. So you have two choices here. You can either go, which ones are seniors and open lot? And that is, so you can go senior, senior, and open lot. That's all of those. I don't know why my pen's not working here. Okay, because he's acting crazy on me. So you can add all those up, or you can take the total of the, just like we did in the beginning, and that is the total seniors and the total open lots, and subtract the overlap. Okay? So when you're doing, keep that in mind when you're doing that. All right, so I'm going to choose, I like this one where I just add all three of them together. Although I'm going to do the other one, sorry. So let's do, because this goes along with the formula. So we're going to have 400 plus 450, don't behave on me, minus my overlap. And what is the overlap of senior and open lot? And that's 275. Okay, I don't have given, so my total is still 650. And that answer is, I think I should make y'all do that. So that gives us 5, come on, don't do that to me. Oh, maybe it's not. It is, my bad. 575 over 650, which becomes 23 over 26. Okay, so as I've said, I've done an example. Make sure you highlight and find the keyword whenever they're asking you those kind of problems, especially if you're doing IXL, to get some extra points. All right, I'm going to start you off on this next problem, and then the rest is going to be up to you. To finish, work in your groups, check your answers. You will be able to check all of these against the answers before you take your test. Okay, in March, 2 types of salmon run in a long river in the Pacific Northwest. Researchers record the salmon as they pass through the fish ladders on the river. 42% of the salmon are Chinook salmon, and the rest are sockeye salmon. So when I get a problem like this, sometimes I go ahead and write all that with the correct notation, and then it helps because all I have to do is use the formula to answer the following questions. Okay, so this one says 42% of the salmon are Chinook. That means the probability of Chinook salmon is 0.42. And if the rest are sockeye, the probability of sockeye would be 1 minus that, because remember, they have to all add up to 1 or 100%, so that's going to be 0.58. Okay, on this next one, of the sockeye salmon. So this is a way of kind of saying, given that it's a sockeye salmon, 35% are male. So what is the probability of male given that it's sockeye? That is 0.35. Well, if it's not male, it's female. So the probability of female, given that it's sockeye, is going to be 1 minus 0.35, which is 0.65. And then come up on the next one. Again, there's my of. So that of is kind of like a given. So probability of male, given that it's Chinook, is 0.45. Oops, didn't close that. Which of course makes the probability of female, given that it's Chinook, 0.55. Now, you don't necessarily have to do all this. I'm just doing it to show you and to remind you when you know one, you can figure out another. Some of these I might have already answered the question. Sometimes you're just going to go plug it in the formula. So what's the probability that a salmon is female given that it's sockeye? We already answered that question. I'm going to let y'all figure that one out. Okay, this next one says, what's the probability that a randomly selected salmon is sockeye and female? Now, I didn't do any of those. So what is the probability of sockeye and female? And that is the probability of sockeye times the probability of female given that it's sockeye. Well, we figured all those out. What's the probability of sockeye? 0.58. What is the probability of female given that it's sockeye? We figured that one out. So now all I'll do is go plug it in my formula. And so when we multiply those out, we get 0.37. So you can leave it as 0.37 or you can write 37%. So that keyword was and. I don't have a frequency table, so I'm not doing it like the ones I did above. I'm using the formula that we have. Okay, so I feel that I've done enough examples for you. The rest is up to you and your groups, and I do wish you the best. And keep working and reading and practicing, and I know it will get easier. Thank you very much.